Good. So in this class, we're going to talk about Google tests. Probably don't need this. So first question before we start talking about Google test is, why do we bother testing? Yeah.
Sometimes a lot easier to go and debug or causing it.
Yeah, pretty much. Like the main reason that we test our code is, we're not perfect, right? We're going to make mistakes, and you probably found that you've made more than your fair share. I know I have too. I make them all the time. And so we want to be able to catch those mistakes before we release our stuff out to the public. So we really want to be thorough when we're doing the testing. Second question is, if you pass all the test cases that either you or I create, does that mean your program's correct? No, what's it mean? Yes, it means you pass those test cases. So testing is not a perfect system. It's going to miss a lot of things. There are some techniques for certain types of programs to prove whether they're correct, but they tend to have to require that your program be written in a certain way, and they also tend to be really slow too, so they only work for small programs as well. So like if you can prove correctness, that's great. But a lot of times we kind of have to settle for this less than ideal thing of that it passes all the things that I can think of, which may not be everything, right? I mean, when you guys submitted your code, how many of you ever submitted your code and thought your code was working perfectly, but then it did not pass all the test cases? Yeah, I was there too, right? So there's always going to be a lot of things that you don't expect. As an example where people tend to make a lot of mistakes is figuring out if two words are anagrams. So two words are anagrams if you can rearrange the letters in the second word to form the first word. And so sometimes like a lot of people might do something like, if every letter in the first word appears in the second word, they must be anagrams. That's not correct, because sometimes the second word might contain more letters that don't appear in the first word. And then some people are like, well, every letter appears in the first word, and every letter appears in the first word appears in the second word, every letter that appears in the second word appears in the first word. Well, that doesn't work, because you might have something like APP and AAP, right? Every letter in the first word appears in the second, every letter in the second appears in the first, but not the same. And they start like, adding on things like, and the lengths are equal. Well, the example I just gave you are the same. Sometimes people try summing the ASCII values of the characters together of the words and seeing if their sums are the same and their lengths are equal. There are test cases you can create that cause that to fail, but it passes most of them, right? So really like one of the important things that when you're testing is you check like all the corner cases you can think of. That tends to be when things go wrong. It's not the normal case. It's not the average case. It's that exceptional weird case where things go wrong. Like, oh, my win happens to be on the edge of the board. Or my win happens to be played from the very last piece that fills up the board. I had that mistake in my code where the very last piece that you played, even if it caused a win, it would still stay as a tie. Right? So those edge cases are the ones that you really want to be looking for when you're testing, but also do test the average case. So let's talk about Google Test. Google Test is a testing framework for unit testing. And there tend to be like two types of tests. One's like units test, where you focus on like that function works, right? And that's what the focus is testing on. And there's like regression testing, which is like testing if like these objects work well together, right? But Google Test doesn't focus on that and doesn't really make it work well for doing those types of tests, like larger tests. So if you want to add Google Test to your program, this is how you do it. I did put a video out earlier before I knew this method, which is a little bit more involved. This one's easier, but it will make your build times a bit longer, because you have to build Google Test as a part of your project, and you also have to download Google Test too the first time. So the first thing that we say is that we need to find the threads package, because Google Test relies on threads, so we go and find that. Then we include the fetch content module. This is a module that's used to pull things from the internet, which is what we're going to use to grab Google Test. To use the fetch content module, you have to do this thing called a fetch declare, which tells you like what's the thing that I want to get, what's its name, where is it at if I don't have it, and then for this particular version, because we're using Git, which branch do we want to pull from? Pull from the master branch. Then we check and see if the thing has already been populated, like do we have this thing or not? If we don't have the thing, go and grab it from the internet. And we're also going to add in our subdirectories too. I'm not sure though, I'm looking at this and this might need to be moved after the end if to make things work correctly. I need to go double check when I get home. But then we target the include directories here to make sure that Google stops complaining, or CLion stops complaining about not being able to find things. A simple test will be like the name of your exe actually, whatever you're creating. And just as a heads up, you can create more than one executable in your CMakeLists.txt. So you might have an executable that you create that's actually your project, right? Your code that you want to be run. Then you might create another executable for actually that does all the tests for Google testing. And then we target in our link library. So whatever your test exe name is, private. If you want to use the stuff from gtest, you put gtest here. If you want the stuff from gMock, you put gMock here. If you want Google's main, you do gtest main. If you don't want any of these things, don't put them here, right? They're all kind of like optional, right? If you don't want to use gMock, don't put gMock. If you want to use your own main for testing, don't include gtest main because then there'll be two mains. Yeah. So you have to include gtest if you want any of the gtest features, right? If you want to use any of the stuff that's included in Google Mock, you have to include gMock. If you want to use Google's main as opposed to your main, gtest main. Yeah. So this is an alternative way of doing it from that was presented in the video that's online. The video has you do like a separate build of Google Test and then link it in later. What this does is it makes Google Test a part of your project submodule that you can build in. This is actually the recommended way of doing things. I just tried doing it the other way first because that's what I found a little bit easier. Then inside gtest or inside your CMake, when you're running CMake on the command line, you would specify -d install gtest equals off because we don't want to install it. To be able to get to these options in CLion, you go to settings, build execution and deployment, then CMake, and it'll give you an option to enter in the parameters. So, right, file settings. It might be a little bit different on Mac. Then under build execution deployment, CMake, for CMake options, I put that option there to be off. There's an example here, which we're going to be going through in a second, called simple tests, and it has an example of what the CMakeLists.txt should look like. Right, most of it's pretty much the same. In my test executable, what's called simple tests. It depends on these other files as well to be built, but pretty much everything else is the same. So if you want to use the Google test, some of the things you have to do is include their headers. So you want the gtest stuff, gtest/gtest.h. You want the gMock stuff, gMock/gMock.h. We'll talk about Google Mock later in the quarter. So most of the tests revolve around assertions and expectations, and these are just double checking that something you expect to happen happens, right? And if this thing that you don't expect to happen happens, the test should fail. The difference between assert and expect is what happens on failure. When you assert and the assert isn't valid, right, it returns false on that check that you were doing, it will kill the test. On expect, the test will still fail, but the remainder of the code will still run. You can also stream output to an assertion or expectation to provide a custom error message along with that failure. Here's an example that I stole off of Google Test documentation. So we are trying to compare here that two vectors had the same contents. So first thing that we do is we check their size. And if their sizes aren't equal, we just kill the test. We're done. We're not going to go any farther. And then what we do is we go through each one of the elements. And if we expect each of the elements of these vectors to be the same. And if they're not, we're going to log the fact that they're different. but we're not going to end the test. So we'll be able to record all of the tests or all the values that are different, not just the first. Any questions so far? Okay. So here's are some of the things that you can assert or expect. You can expect some condition is true or false. You can check that two values are the same, different, less than, greater than, less than or equal to, greater than or equal to. These comparisons are all going to call the overloaded operators for that class if you're testing a class. So like if you don't provide an equals equals, you can't do assert equals my class to another version of my class. But you could do assert true on some complicated expression where it basically says they're equivalent. There are also some things for doing C-string comparisons, and I do recommend looking at the gtest documentation, how it works. That's the advanced stuff. So like here's the C-string comparisons. If you're just doing like comparisons between like the STL strings, you would use like assert equal, assert less than, assert greater than. So are these two C strings the same? Are they different? Are they the same regardless of case? Are they different regardless of case? So when you want to write a basic test, it's test, should be probably all in caps, test suite name, test name. Test suite name is like the group of tests that you want this test to belong to. Test name is the name of this test. And then again, inside this code, you'd have at least one assert or expect somewhere. So like here might be a little example of testing whether some factorial code worked. So it belongs to factorial test as a test suite. And you want, this one is checking to see that it handles 0 correctly. And this one's trying to see that it handles positive numbers correctly. Any questions so far? So over here, again, is simple test. One thing to note is with like standalone code, full test can't test that. So all the code that you're testing either needs to be inside of a class or inside of a namespace. So here, just because I'm doing Fibonacci and Fibonacci doesn't really belong inside of a class, I had to go put it inside of a namespace called fibbing. Does that make sense? So if these pieces of code were not inside this namespace, Google Test can't test it. Just a weird restriction. And then over here, I have some tests. So I include gtest/dtest.h so I can do the testing. And then, I check that, base case 0 works. Base case 1 works on my slow Fibonacci. I do my recursive case with 2, 3, 4, 5 to make sure that the values are what I expect them to be. These pieces of code are pretty simple because testing Fibonacci is a very simple idea. But I'll show you, if we still have time at the end, walk you through a little bit more of the tests that I was using for your homework assignment right now. Any questions so far? Yeah. You mean you want like a thing inside a thing inside a thing that then has a test? Yeah. So the only way that you could kind of get that behavior is with you kind of like doing a naming convention kind of scheme, like level 1 underscore level 2 underscore level 3, comma, my test name. And it's really not going to put it inside of it, but it gives you that illusion that it is inside of it. But it's something that you'd have to enforce at the programmer level. Any other questions? Okay. So sometimes, again, with like doing a lot of tests, you might have a lot of common code in between those pieces, or between those tests. So of course you can write functions and call functions inside your tests. No problem. The other thing that you might decide to do is if you have a lot of commonly reused data, is you can put that commonly used data inside of a test fixture. So a test fixture is a class that inherits from testing : test, hey, inheritance. And members that you want to access inside of this test fixture either should be public or private. What this test fixture is going to do is at the start of each test, it's going to call the constructor to initialize things, then call a setup function, do whatever you want there. Then your test will run, and you can use members inside that fixture to do whatever you want. Then tear down will be called to undo whatever you did inside of setup. And then the destructor will be called to undo whatever you do inside of the constructor. A new fixture is going to be created for every single test. So if you modify the test fixture in one test, you don't have to worry about those changes showing up in another test. And again, with this setup, you can put those similar data objects as members of that test fixture class. If you want to declare a text fixture, it looks like this: class myFixture : public, testing : test, protected or public, whatever you want accessible inside the test at this level. And then you would write those members or methods, or at least declare them, and then go write them in the implementation. So they give this example over here for testing in the test fixture. So what they want to test is their queue class, and their queue class has the ability to enqueue elements and dequeue elements. Like a queue is just another name for a line, right? People enqueue, they get to the end of the line, or they dequeue, they leave the front of the line. And so they define this test fixture over here. And then inside setup, inside the test fixture, they have 3 separate queues: Q0, Q1, Q2. They all happen to be queues of ints. And then in setup, they decide to put the value 1 inside Q1, the value 2 inside Q2, and the value 3 inside Q3. So now these members, Q1, Q2, Q3, are accessible inside the tests, and this piece of code will always be run at them at the beginning of each test. So what they might be they test right here to say, hey, is this thing going to be initially empty when I first create it? And so they expect equal Q0 to be of size 0. And back here in the test fixture, they didn't put anything inside Q0, so it should be 0, right? In there. Then they're trying to test that dequeue works in different ways. So they attempt to dequeue from Q0, which was again empty, so they expect to get the null pointer back. They dequeue from Q1, so they expect it not to be equal to the null pointer because there's something inside there. And they expect that value to be 1. It's the first thing they put in. And then again, after we dequeue, since they only put one thing inside Q1, we expect it to be empty. And they delete it. And then they do something similar on Q2 to test that it's working. When you're trying to create a test using the test fixture, instead of using just test, you have to use test _ f. And the first parameter here can't just be the name of anything. It has to be the name of the fixture class that you created earlier on. So notice the class name is qtest here. So for using the test fixture, it has to be qtest here. Any questions so far? Generally, most of the work is supposed to be done inside the constructor. There are some occasions where you might need to do stuff inside setup. And if you want more details as to when something has to be done in setup and then taken down and tear down, feel free to read this link here. The other thing is that setup and the constructor, they always have to have 0 arguments. So you can't have a test fixture whose constructor accepts more than 0 arguments, which kind of sucks, but it's not doable. And talked about that. So some other things you might want to be able to do is succeed. You just say, hey, this thing worked so far. Great. A fail will generate a fatal message, and you can stream an error message to it. You can say add failure at some location. This is going to generate a non-fatal failure at that location, so like an expectation kind of failure. You can stream a message to it, and these guys are really useful if you want to test control flow logic and not test like data values, right? You want to make sure that you never go inside this if statement, or you never go inside the default case because everything should be handled. You can assert that I don't go there, right? And so like the example that they give, Google test. This one. So right, they're like, hey, the default case, we shouldn't go here. So they have it fail if it ever reaches that spot. One thing to note though is that fail and assert can only be used inside functions that return void. They can't be used inside functions that do not return void. The workaround for this, if you really want to, you could, instead of asserting, you could, have an expectation and then check to see if it was met after the function completes. Or if you really do want to use an assert or fail, you could change the function so that it returns the values throughout parameters like we saw before, right? Pass references in, modify those things, and now you can return void instead of returning that parameter. And then you can assert inside of it. One other thing that's kind of weird is like when I was first reading this, I would assume that if you had a fatal failure inside of a function that you called, that my entire test would just be killed. It doesn't, it just kills that function. So watch out for that if you're working with this. The way that you can test to see that something failed or not when the function that you call is by using assert or expect no fatal failure, or you can check the HasFatal failure member method. So if it got called again, it would get called again and then probably die again. But it depends, because maybe that function only failed because of the parameters you passed to it. And now this new time around, it doesn't fail. So overall, though, the test would still fail. The more worrisome thing is maybe you call some function that's supposed to give you a pointer back, right? And inside that function, you assert that if this thing happens, you should die. But now your pointer was never set to be what it was supposed to be, and then you attempt to dereference the pointer, and now you get a segmentation fault. So that's the more worrisome thing to watch out for, because you kind of were assuming that control of my function was supposed to stop here, so you didn't check to see that things are still good. So if you want to the assert or expect, you say assert no fatal failure, and then you can put anything you want here. It could be any statement. So it could be a function call. Great. You can even do multiple lines of code by putting curly brackets here and then saying the code that you want to do. Also, what you could do is you could check the HasFatal failure. So you call some function that might fail, and then if something has failed, you can say if HasFatal failure, and then you can stop your test there by either return or explicit fail inside yourself. One cool thing that comes from gMock, which hopefully, again, we'll have time to talk about later, are matchers. Matchers allow you to check against some type of pattern. They allow you to test things like, does a string start with something? Does a string end with something? Does a container contain these values? Does a container have some of these values? Right? Does this string contain this regular expression? And if you want to use them, you have to include gMock/gMock.h and then make sure that you link in gMock. And then you use the assert that or expect that, and then you say some value with whatever the matcher happens to be. Again, the matchers can be found over here. So in your matcher, an underscore means anything, just FYI. And then, we have equals, greater than or equal to, right? All the comparisons that you would expect. These ones, aren't so cool. But then down here, you have string matchers hey, does this string match this regular expression? Does it end with something? Does this contain some substring? Again, matches the regular expression starting at the first character and ending at the last character, so the whole thing matches. Does it start with something? Again, case equal or not equal to some string. Container matches is you can check this container match something else. You can see if it contains something. You can see if each element, right, has that value, or it could be a matcher. So what you could say, if you had some vector, you could say I assert that this vector, right, each value is greater than or equal to 5. And then it would check to see that everything inside that vector is greater than or equal to 5. Right? And you don't have to do it manually. which is pretty nice. You could check to see that the elements are these values. Again, you can check with an array as well. Its size is something. The elements appear inside there, but they can be in any order, or the elements are there when it's sorted. You can sort by comparator. And there are some other things that are useful, for example, like all of or any of or not. So you can provide multiple matchers. So like, do all of these conditions hold? Do any of these conditions hold? Then it's valid. This can allow you to do some pretty complex testing with a fairly small amount of code. But I haven't really used them that much because I didn't really know that they existed. So yeah. So you can say, like, I want to assert that this string starts with hello, and I'll check that string does indeed start with hello. One thing that I like to do, especially like when I'm testing your guys' test, is to test based on some values. Like, here's the input, right? Is everything working out correctly? And so we might want to have different test cases that take in different values. These would be parameterized tests. In order to make a parameterized test, you have to inherit from testing with param t, where you'd plug into t the type of the parameter that you're looking to test, right? So if your parameters are going to be integers, integers. If your parameters are going to be doubles, doubles. Your parameters are going to be strings, string inside there. Instead of using test, you use test underscore p, the name of your test fixture, and again, whatever your name is. Inside the test, you can get the parameter you're working on with get param, and you can instantiate an instance of that test using instantiate test suite underscore p. You give some unique name that's going to be prepended to each test, so you're able to differentiate it between different instantiations. Because you might, try to create these tests using this set of values, 5, 7, 9, 10. But now I want to test it again using 3, 6, and 12. So you can instantiate it different times, but you have to, put a different name on it to help you tell these tests apart. Then you provide a parameter generator. A parameter generator can be either range, values, values in, bool, or combine. Range will again give you some value beginning at begin, ending at end, and the step will be increased by whatever. And notice that the documentation says that the first value is begin, then begin plus step, then begin plus step plus step plus step, then begin plus step plus step plus step plus step. So you wouldn't have to use range with just like a numeric value. If you had something that had plus defined on it, right? Your own class that had plus defined on it, you could pass it in there with a range, right? Here's my object class that I want to start at as begin. Here's my object class that I want to start at as end. And then plus along the way. Values are going to be these values. Values in some container. You have a vector or an array you can put there and have the values listed. Values in some range between two iterators. Bool will just give you true and false. And then combine accepts a whole bunch of generators and gives you like all the combinations of possible values pulled from all these generators. So what I did back here is I did this, but I got a little bit lazy because I didn't really want to do anything inside of my test parameter class that I created. I just wanted it to exist so I could use it. So I said using fastfib param test equals testing : test with param type int, right? That's its name. And so basically there's an instance of that class that didn't actually inherit, even though you probably should inherit, but I was being lazy and didn't want to write all the code of this type parameter. So here's my test P. It's testing my fast Fibonacci implementation, and it's asserting that the slow Fibonacci and the fast Fibonacci have the same values. And then I use get param to get those values. And so I tried instantiating this particular test suite with the range between 0 and 10. One thing that I feel like I don't like about these parameterized tests is that you have to build that test suite class for like each different type of test really, because normally I don't want to give multiple tests the same input. Does that make sense? Right? Because if I had some other test that I wanted to create here, that was again still over this fast fib param test, like still over this thing of integers, it gets the exact same arguments here for all of them, which like I don't understand that design decision, because normally I want each test case to receive different inputs, right? test 1 and test 2 and test 3, these functions probably need different sets of input values. So to actually get that to work, you'd have to have a different test suite for each one. Yeah, I know, it's weird. But you would. Yeah. So if you didn't want to do it this way, you could have like some for loop that has the values that you then go through and you do it inside the test, or you hard code the values inside the test itself, which can definitely work. It just seemed like it's like, oh yeah, this is exactly what I want, but I'm like, oh well, not really, I guess. Yeah. So this just gives you the option to test, and you know, this is just going to build like any other program you've built before, and then you'll get some output like this that tells you like which tests you passed and the total number of tests run. Right? If we had made some mistake, like maybe back here I accidentally had put something like, oh, not here. Like maybe here I accidentally returned 0 instead of 1, and we go and we compile. And you're like, oh man, failed, right? And it's going to tell you like what it expected to happen. So it's like, hey, when we ran slow fib, we expected these values to be equal, 1 and fibbing slow fib of value 0, but it actually was 0. This test case failed. And it will also tell you whether the test case ran or not. You've also probably noticed, at least I'm not sure, how many for you, like when you compile, it takes a lot longer now for this particular homework problem. At least for me, it's like, and then like it finally like compiles after a while. This is because like all of the homework that you're doing involves templating, which requires the compiler to create code before it can then compile it. And then the Google test also uses a lot of like macros, which are like kind of like functions, but they do text substitution. And so that is used to produce more code, which then has to be compiled. So it's a lot of extra code being produced that has to be compiled first. Do you guys have any questions about Google Test right now? Yeah. No, it's still a single pass compiler. Like when it goes and analyzes your source code, it starts at the top, goes to the bottom, goes through once. That's why we still have those 4 like circular inclusion issues that cause things to break. Any other questions? Yeah. Right. I mean, like if we pop on over to like the AA link list stuff that you're doing, I'm really just like checking, like if I push something to the front of the list, is it at the front of the list? Push something to the back of the list, is it at the back of the list? You know, if I remove a list that only contains one element, is it empty? Right? So it's just checking like a lot of common sense things that like my expectations of what I think should be happening are indeed actually happening. I also encourage you to go ahead and read the Google Test documentation. Just search for Google Test and it'll bring you to like the Google Test primer. Read that and then also read the Google Test Advanced as well, because there's a lot of stuff in there for using more advanced options like the parameterized tests. Or over here, I actually have type test, right? Because I want to be able to test your function over different types, like, oh, does it work with integers? Does it work with strings? You know, are you templated? And I can make the class work. So if you want to do type test, which is what I did over here, to do type test, you have to template your class and then inherit from testing : test. Inside of here, what I did is I had vectors that basically stored the arguments for different tests later on. Then over here in double-linked-list.txt, you say, well, what types do you want to use for your tests? Well, I want to use integers and strings. And this using requirement, using the using keyword here to do the alias is required, because otherwise this macro doesn't parse correctly. So then I say, hey, I want to make some type test suites of my double-linked list test, the guy that you saw back on the previous page, over these types. And we'll create different versions of the test for that. So over here, for example, like the first test is you create an empty list, and I check to see that it's really empty. So a lot of the tests that I had to do for like being empty required me to do a lot of the same work over and over again. So I wrote some functions to allow me to check that. For example, the ones that I have here are DLL and your double linked list and your vector. Are they going to be the same thing at the end of the day? When you're inside these type tests, you can use type param to refer to the type of the test that you're working on. So in one version, it's going to be int, and another version is going to be string. So this function returns something called a testing assertion result, which is more or less a glorified true or false, but it allows you to put some error message into it if it fails, or if it succeeds, your choice. So what I tried doing first is checking to see that both your vector or your linked list and the vector have the same size. If not, I complain and I give an assertion failure back. Then I make some iterators that go forward. And then I check over here using this big old long nest. Basically, are the like if I iterate using these forward iterators, do I get the same values back? All right, so if I iterate forward through your list and I iterate forward through the vector, do I get the same values? Then I check to see if I go backwards and reverse, do I get the same things? If it fails anywhere along the way, I'm going to fail you. And then if it gets all the way through, you get success. Yeah. Pretty much. And the other thing is like where they start, the reverse iterator starts at the end, where the tail one begins at the beginning. So if you want to, which is actually kind of a cool thing that you can do now, because we talked about inheritance a little bit, if you want to do more, you could have your reverse iterator inherit from your forward iterator, right? But then you could override how plus plus and minus minus work. And so you can have your child, like let's say reverse inherited from forward. So you can say, oh, in my plus plus, I want to call my parents minus minus. In my minus minus, I want to call my parents plus plus. Great, you're done. You have reverse iterators now, assuming your forward iterator works correctly. Right? This is why like inheritance is really useful, because like a reverse iterator is pretty much the same thing as a forward iterator, except we need to modify some of the behavior, the plus plusing. Yeah. So, You don't need to mess with the iterator's position. I'm assuming that after I erase or insert something using an iterator, all iterators I have are invalid. So I will not try to dereference it or use those iterators anywhere else after I've used them for an insertion or deletion. If I want to go do more insertions or deletions, I'll request a new iterator from your begin methods and then move to some spot and throw things in. Yeah, you're good. Some things that you see here are type name. Sometimes our types are what's called dependent, and the compiler has a hard time parsing those. And so what'll happen is, like, since this type over here refers on this type over here, I have to put type name here to say that this really is the name of a type and not something else. I never know exactly when I have to put type name, but the compiler will complain at you that this thing is supposed to be trying to be parsed as a type, but it's not a type. If you want it to be, parsed as a type, put type name there. I'm like, okay, type name, great. That's what I wanted. So that's how I figure out that problem of whether I need type name or not. The compiler complains at me to add it, I put it there. This guy over here that like tests whether these things are the same is, nice and fun. He's, templated over two types, the iterators type of your doubly linked list and your vectors iterator. It's allowed me to write one function that allowed me to test both your forward iterators and your reverse iterators, so I didn't have to do it twice. And so we take the iterators and we go from the beginning to the end. If they don't match, I complain. If they do match, we keep going. So basically here I'm just checking that, both these vectors have this, both your linked list has the same number of elements as the vector, and when I iterate over them going forwards and backwards, I get the same answers. So one thing that you're going to see here that's a little bit different is, hey, look at this template. What's its type? It doesn't have one. So this is what's called a template specialization. So you can provide your generic template of some type, but maybe for certain types, you can do a better job of implementing it. So then you would provide a specialization. And specialization is like, okay, on this type, I'm going to do this as opposed to the generic code. So for me, if I have a doubly linked list test of type int, I want to make its constructor args value 1, 2, 3, 4, 5, 6. That's all it says. But if I have one of types, if I have one of type string over here, I want to make its constructor arguments Bobcat, Sally, Man. Right? So the specializations allow you to control for that particular type what happens. And this is actually how I'm able to create different arguments for the different types. I had to go look on Stack Overflow how to do this, because like, how do you do this? How do I give it different arguments for the different types when I don't know what the type of the test is going to be? And that was their suggestion. Any questions here on the specialization? And if we had some other instance of a doubly linked test that's not of type int and not of type string, its arguments are kind of undefined. So again, these tests are pretty simple. So there's the vector constructor. So I call your doubly linked list on the vector constructor. I give it a vector of arguments, and I test that, hey, does your doubly linked list and that vector the same? Great. Right. So here's some push front arguments and push back arguments. I might do something where I push something to the front, and then I check the thing at the front is what I put there. Right. So most of these tests aren't interesting, cool, super crazy code. They're just hey, is everything that I expect to be happening actually indeed happening as it should? And some of these tests actually help me catch errors in my own code as I was writing them. Right? Or this test is testing that, hey, after I push front, and the only thing that was if your list was empty and I push front once, our head and tail point to the same thing. Right? Is the front and the back the same? So just trying out different combinations of tests. Do you guys have any questions here about these tests? Yeah. So that there is a portion of code that runs through both your doubly linked list and the answer vector to make sure the values in them are the same. So if that's what you mean by hard coding to check to see that they're equal, yes. So is your question did Google Test write any of this? No. I wrote this. All 400 lines in here are stuff that I put.
Have to come up with a test kit.
Of course, how is something supposed to know how your program's supposed to work, right? How is any program supposed to know how any other generic program is supposed to behave? It's not. So yeah, you have to write all your own test cases. This just gives you a platform or a controlled way of specifying the tests that you want to run. Wait, we got 5 minutes. Any other questions? Yeah.
The way
Yeah, so it's doing all these tests, and each test case that I have on Google Tests says to run exactly one of the tests from this selection of tests. Any other questions? Yes. So the question is, can you have Google Tests generate random values for your test? No, you can't, but you can have it so that you generate random values by using things like random numbers. Right? Did you guys do random numbers in 36A? Yeah, so you have the ability to do randomness inside C++ as well. So, oh, you guys didn't do anything with random either? Well, yeah, just a function call, but you know, you need to do it at least once to have an idea of how it's done. Okay, we'll try to make sure that we throw some random stuff in your homework too. But like, for example, like one of the tests, right, that I have down here, for like insertion, because you know I get lazy sometimes, is like this guy right here. He creates like your vector and fills it up, and then he randomly picks positions inside your vector to erase. Right. So here is me doing something with random. So rand generates a random number between like 0 and rand max. And so I mod by the size of my vector to get a number between that's like in bounds of my vector. And then I advance my iterator to that position that I want to delete. And then I have, you know, both the answer vector and your doubly linked list erase that position to make sure that, and then I check afterwards to, hey, are you the same? The same. I keep checking every time I delete something that you and the answer vector have the same set of values. And like some things that I did here, like asserting true that these things are the same, right? I write that big old test like the size are the same and the blah 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 is the same. This could have been done a lot easier. I wouldn't have had to write that if I had used the matchers inside GoogleMock. Right? This like DLL and vector match could have been implemented using where did it go? Here. It could have been checked using elements are this, or maybe not container equals. Maybe not, because we don't have an equals equals operator defined on them. I guess I could have defined an equals equals operator, but that's like the same work. Oh, okay. I guess I could have used elements are array and then pass in the vector there. And then that would have saved me from having to write all that code. Right? I could have said, like, instead of the assertion that I have over here, like assert true, DLL, and vector match, I could have used assert that, you know, DLL elements are answer vec. And that would have done it. You guys have more questions? Yeah. Yeah, and there's like the ones that Python just say run a particular test for each test case to make sure that you're passing that one. You get points for each individual thing that you're able to do that I could think of. So yes, in theory, if it works on your system and you're passing all the tests, it'll work on Codathon. And so there's really no reason for you to keep submitting to Codathon if it's not working on your machine. The only thing where behavior might be different is undefined behavior. So if your program has undefined behavior, it might work on your machine, but not work if you upload it on Codathon because the behavior is undefined. One other question I have before we go. How many of you guys actually test your own code? How many of you are actually looking at whether your code is behaving correctly before you submit to Codathon? Or like for your homework and stuff. You know, how many of you are checking like for like the N-curses connect in? How many of you are checking that everything was working out correctly before you submitted? And then how many of you just relying on the testing provided by Codathon? Okay, good. You do want to be testing things, trying out everything, exercising your own logic, because writing these test cases for you guys, it's great for me in testing and evaluating you automatically, but I always fear that sometimes it diminishes your ability to test your own code, right? Your ability to figure out what's going wrong. Because that needs to be a good programmer, you have to be able to figure out what's going wrong with your stuff so you can figure out how to fix it. I will see you guys in class on Monday. We'll talk more about inheritance.